Alright, let's get started. My name is Akshaya and this is my final presentation for lab 1 on the amount of excess charge on a piece of tape. So this lab is going to use normal objects and the idea of charge to find the amount of excess charge on a piece of tape. The fundamental principles involved here are Newton's second law, Coulomb's law, and the idea that ordinary objects can have a net positive charge when rubbed or pulled apart. We anticipate the charge on the tape to be between 1.6 times 10 to the negative 19th coulombs and 1 times 10 to the 5th coulombs. So the setup and the initial charge observations involve creating a base tape of about 20 centimeters and laying another piece of tape on top of that tape and pulling them apart quickly, which will create a charge on the tape that was pulled off the base tape. And this charge is expected to be positive, and we can observe that it is in fact positive when we see its interaction with a negatively charged plastic. So in this video, the highlighter was negatively charged, and you can see the attraction between the tape and the highlighter. So now that we've established the basics, the lab actually is trying to balance gravitational and electrical forces by creating a U-tape that floats above another U-tape. So here in this figure, we see a U-tape B suspended between two books, and then a U-tape A below that U-tape B, which actually repels tape B and causes it to balance out with gravitational force, allowing it to levitate. So here you can see me setting that part up. So I prepared two U-tapes and I tested each U-tape to check if a charge is present, which in fact it was, and then I attached both ends of the first U-tape to binders to form a bridge with a dip, and I had a little problem where I seemed to repeatedly lose charge once I adhered it to both sides, and there was no repulsion between tapes A and B. So that actually comes up in one of the post-lab questions, where if you handle the tape too much, you actually end up losing the charge on the tape. So eventually I overcame that and I got the separation distance to be about 1 centimeter, so 0.01 meters will be appearing in my code and my calculations. So here in my calculations, you can see that I equated the electric force and the gravitational force, and the mass of the tape was approximately 0.0002 kilograms. And I found the charge on tape B to be 4.66 times 10 to the negative 9th coulombs, and that was right within the accepted range for that value. And I found the area of the tape to be 1 times 10 to the 18th atoms, which then gave me that there were approximately 2.92 times 10 to the 10th electrons on the piece of tape. And we can see that repeated as the values from my code once it ran. So here is a snapshot of my code. You can see that I created both the tapes as particles. I made the assumption and treated them as particles, point charges here. And I calculated the gravitational force on tape B and the electric force on tape B using the electric field created by tape A onto tape B. And if we jump over to the code real quick and we run it, we can see that this green arrow here represents the gravitational force on tape B, and then this orange arrow here is the electric force on tape B by tape A. So B is represented by the red particle and A is represented by this blue particle, and then we can see that the values here agree with the values I manually calculated. The gravitational force is 1.96 times 10 to the negative 3rd. The charge on tape B is 4.66 times 10 to the negative 9th. And the number of electrons on tape B is 2.91 times 10 to the 10th. So again, they agreed with my manually calculated values. So if we go back to this presentation, there are a few questions I haven't hit on. I covered all the experiment questions and the first coding question. So this coding question on the right, as far as the assumptions I made to estimate the amount of charge on the floating tape, I did assume that the entire tape, I considered it to be a point charge in my calculations and assumed that the electric field was uniform. And as for the other post-lab question I didn't answer, what if the electrons had a positive charge and protons had a negative charge? For our purpose, We're really looking at the repulsion between the two tapes, so even if the tapes had been negatively charged, they still would have repelled because like repels like. And as far as other charged objects go, again, even if positive and negative charges had switched, you'd still experience attraction and repulsion the same way you would with the like repels like, and the opposites attract. And that is it for my final presentation for Lab 1.